Okay, so today we're going to talk about is verifying trig identities. Okay, this little screenshot right here comes from the PDF that I've uploaded to Google Classroom, and these are just some strategies that you can use when you're verifying trig identities, one side to the other side. Okay, one of the biggest things that I want you to focus on is I want you to focus on working on the more complicated side. Okay, so it's a lot easier to make things smaller than it is to make things larger. Okay, so you can kind of refer back to this as we go. Okay, we're going to mainly work on one side. So that's kind of the thing. So work on one side and by just manipulation. So by manipulating it, don't move anything to the other side. Okay. And again, these are just some strategies. I like to pay attention to the fractions, right? So we can combine or we can separate fractions. So that is important. Every now and then we will work both sides of the equation when we do get stuck, but for the most part, we should be able to do that. We shouldn't need to work on both sides. Okay, so let's start with one that's easy to begin with. So we'll call this number 1. So sine squared of x all over cosine squared of x plus sine of x cosecant of x is equal to secant squared of x. So when I look at this problem, I notice that the left-hand side is a little bit more complicated to the right-hand side. So basically what I'm going to do is I'm going to leave the highlighted side alone, and I'm going to try to focus on the left-hand side. So how do I do that? Okay, I'm going to try to use my algebra skills and my fundamental identities to help me. So the first identity that I notice is that there is a sine over a cosine. They're both squared. So I'm going to change that to a tangent. So I see a tangent plus sine of x cosecant of x. Now, if you want to combine a couple steps into one, that's fine. Okay, I noticed that cosecant and sine, they're reciprocals of each other. So you don't have to show this step over here where you're turning it into 1 over sine and you're crossing it out. As long as you know they're reciprocals of each other, we can just immediately write that it's plus 1. Together, tangent squared of x plus 1, that is a Pythagorean identity. So the right side is in fact equal to the left-hand side. So we now have manipulated it together. All right. So let's try another one. So number 2. So let's say secant of theta cosecant of theta is equal to tangent of theta plus cotangent of theta. And again, at any time you want to pause the video and try this on your own, that's fine too. You will have the opportunity later on. All right, so looking at this problem, I noticed that the right side this time seems a little bit more complicated. Sometimes it's easier to get rid of an addition sign than it is to create one. So I'm going to go ahead and not touch the left-hand side this time. Now, when in doubt and I'm struggling and I don't know what to do, I always change things to sines and cosines. So this will become sine of theta over cosine of theta, and then this will become cosine of theta over sine of theta. I now notice that they're fractions. Fractions have to have common denominators. So this has a cosine, but it is missing a sine. So I can multiply top and bottom by the same fraction, which gives us 1 essentially. And I could do the same thing over here. Okay, so what does that give me now? That gives me sine squared of theta all over my denominator, sine of theta, cosine of theta, and then cosine squared of theta all over sine of theta, cosine of theta. Same denominator, so I get to write it as one fraction, which is exciting. And I notice that sine squared plus cosine squared, that is a Pythagorean identity, so that's just equal to 1. So now it looks like I've gotten rid of my addition sign. Now I see two things being multiplied. And so I'm always referring back to the other side of kind of what's happening. So I know a secant is really 1 over cosine, and cosecant is really 1 over sine, and that's essentially what I have. So this is just a little extra step. So 1 over sine and 1 over cosine. So I'm breaking up this fraction into two fractions using multiplication. And again, I just want to point out that you know, the commutative property of multiplication or addition, right? 5 plus 2 is the same thing as 2 plus 5, or 5 times 2 is the same thing as 2 times 5. So it doesn't really matter which one we have to write first, right? So 1 over sine, that's the same thing as cosecant of theta. 1 over cosine, that's the same thing as secant of theta. Notice that this side is exactly the same as the other side. So we're done. Check. All right. So let's get into a harder one. Right. So sometimes these will take up a majority of your page. So what happens if we have something that looks like this? Secant of x minus 1, 1 minus cosine of x is equal to the secant of x. Okay, so it looks like a fraction, right? Or it doesn't look like it, it is a fraction. We can't separate them because we have a binomial in the denominator, so I can't make it, you know, the 1 into one fraction and the negative cosine into the other fraction. But anytime I see like 1 minus something, right, a trig, my head always goes to Pythagorean identity. But the problem is, right, if I think about the Pythagorean identity, it has to be squared, right? So the only way to make it squared is using this guy right here, the conjugate. So anytime I multiply by a conjugate, I get to end up being a difference of two squares, and then I can simplify my problem. So sometimes that is helpful. This is just one way to perform this problem. So that's what I'm going to do. I'm going to multiply 1 plus cosine to the top and the bottom. Because again, the left-hand side looks a little bit more complicated than the right-hand side. So I'm going to distribute, so this will become secant of x minus 1 plus cosine of x, secant of x, and then minus cosine of x. And then in my denominator, this will give me 1 minus cosine of x plus cosine of x minus cosine squared of x. Okay. So a couple things. I notice that this guy right here, those are reciprocals of each other, so I know that that equals 1. And I notice that this guy right here will cancel each other out. So I have secant of x minus 1 plus 1 minus cosine of x. And then this now is 1 minus cosine squared of x. So again, my ultimate goal is just to get it to be secant, so I've got to make that kind of go away. So what else can I do? I can combine those terms, and they can go away. So secant of x minus cosine of x. And then in my denominator, 1 minus cosine, I'm just going to write it as sine for right now. Okay, so I've at least gotten rid of my denominator as a binomial. It's now just a monomial. So what I like to do is I like to separate my numerator and denominator. And how I do that is by writing a division sign instead. So I'm going to write it as division. And now I look at my numerator and I can kind of just focus on what is secant of x minus cosine. And again, when in doubt, change things to sines and cosines. So I'm going to bring it up over here, and I'm going to change secant to make it 1 minus cosine of x. And then this becomes cosine, and since it's a fraction, I'll put that also as a fraction. Divided by sine, so that's the same thing as multiplying by the reciprocal, so I'll write it like that. Again, these are fractions, so let's go ahead and combine them together with the same denominator. So I would do that by multiplying top and bottom by cosine of x. So this would become 1 minus cosine squared of x all over cosine of x. So I basically did 2 steps in one right there, right? So this is really 1 minus cosine of x minus cosine squared of x over cosine of x. That's what I did. Okay. 1 minus cosine squared of x, that's the same thing as sine. So now notice that I've gotten rid of my addition or my subtraction sign again. And now notice that the signs, they cancel out. You're left with 1 over cosine of x, which is the same thing as secant of x. Okay. All right, so this one was definitely a little trickier. Okay, so for the next problem, what I want you to do is, for number 4, I want you to try to pause the video and pick a side that you're going to work on and try to get the other side to look like it. When you unpause the video, if the side you're working on is the same side that I chose to work on, I want you just to put your initials down to of where like you stopped. And it's okay. You can give yourself just a couple minutes to work on it. If I pick the other side, then copy it down. So basically, I want to see your work that you're going to try to attempt, and then I also want to make sure you have the right answer down. So again, go ahead and pause the video right now and try that out. Okay, so if you're coming back from the pause video, right, what I ended up doing is I ended up keeping the left-hand side alone. So I manipulated the right-hand side. So I manipulated it kind of like the last problem. I first multiplied the top and bottom by 1 plus sine squared of x. So if you manipulated this side too, make sure you have that correct. So you ended up getting cosine of x plus cosine of x sine of x. And again, these are difference of squares. So if you think about this, this really gives you 1 minus sine of x plus sine of x minus sine squared of x. So again, these two are going to cancel out. So we can just write 1 minus sine squared of x. The denominator then is going to become cosine squared of x. I see that it's not written as a fraction, so what I'm going to do is I'm going to break up my fractions. So I'm going to put cosine squared into the denominator of both. I just realized I wrote squared here, which it should not be. So the cosine is going to go away, and the squared sign will go away there. So this will just be 1 over cosine of x. This cosine and this squared will also go away, so it just leaves you sine of x, cosine of x. And then 1 over cosine, that's the same thing as secant. And then this is the same thing as tangent. So the right side and the left side are now equal to each other. So if you, in a couple minutes, you were able to solve all of it and it looks kind of similar to what I have, go ahead and just put your initials at the end. If this was the step that you stopped working on when you pressed unpause, then just go ahead and put your initials. And again, if you did the other side, I just kind of want to see what's happening. All right, so let's try one more, and we're going to do the same thing on this one. So you're going to press pause just a second. So this is the cosecant of negative x minus the sine of negative x all over the sine of negative x is equal to cotangent squared of x. Okay, so go ahead, pause the video and see how far you get. Give yourself a couple minutes and then unpause the video. I'm doing the same thing. All right, so if you're unpausing the video, hopefully what you recognized is that the left-hand side is a little bit more complicated, so you probably didn't touch the cotangent squared. So the first thing I would do is I need to get rid of these negatives. So I'm going to pull them out. So it becomes negative cosecant of x. The negative and the negative here will turn into a positive sine of x, and then this will become a negative sine of x. What I like to do at this point is, again, break up my fractions. So negative sine of x goes there, and then sine of x, negative sine of x goes there. The two negatives are going to cancel each other out. Again, I know that cosecant of x is the same thing as 1 over sine of x, so I can kind of drop everything into the denominator there. And then the negative will make the addition sign go away, make it become make the addition sign become a negative, and then sine over sine is just 1. Sine times sine is sine squared minus 1, and then this becomes cosecant squared of x minus 1. Using your Pythagorean identity, that is the same thing as cotangent squared of x. Okay, and now we have solved it. Okay, so the only way to get better with these is obviously with more practice, right? There's no wrong first step as long as it is mathematically correct. Good luck.